All right. I want to thank you for your patience, first off, and I want to thank Jim for inviting me. I think perhaps you didn't realize that this is one of my favorite sort of black sheep topics to bring in, talking about ISRU and local materials in a really hands-on context, in the context of actually taking the material that we've mapped and that we've sampled and transforming it into what we need to use. So what I was thinking about yesterday as I listened to Jim's first presentation and Jake and Kelsey, and then Jim presenting Dean's work as well, was how this hands-on building perspective fits. We can go to the next slide. How this hands-on building perspective fits in terms of the overall program of work that we have ahead of us, and how it fits into discussions that in the present are anchored very much in geologic mapping. And I had a sort of light bulb insight as Kelsey was talking about the Jet 3 and Jet 5 exercises. Because I often have thought, while working in the field of the science and geology and EVA type exercises, as being part of what the other teams are doing, but not necessarily my work, which I undertook in terms of the field logistics and site scouting and very practical preparations. But as Kelsey was showing the maps and details and putting the photos in context, I saw myself 15 years ago assessing the construction defects and in effect assessing construction defects on construction sites where people were sending me photos from 2,000 miles away, and I was looking at mineral materials as they'd been used in situ and looking at the difficulties that they were having, and in effect acting as the back room to their field eyes. So in effect, what I want to talk about today is how we transition from these geologic maps to living off the land, and how we move into building the data infrastructure and data products that will allow us to populate our maps with the additional layers of information and calculated values that allow us to make the very complex decisions about what we'll build, about how we'll configure the systems of systems that we'll need to build the infrastructure that will sustain human exploration over the longer term on the moon and beyond. Next slide, please. So we're making a big leap from geologic maps to living off the land, and you know, we're bringing in the geologic maps and thinking about the environment, the terrain, and topography. Some of those maps we have, some of those maps we need more of in greater detail, and some of those maps we still need entirely. And we need to not only source those maps, but we need to really define the layers of information that we're seeking. And in terms of building out that ISRU value chain and integrating it with the data for the candidate sites, we need to be defining the layers of information that different stakeholders will want to add, that they'll want to draw from, and we'll need to be defining the catalogs of systems, of processes, of materials formulations that will be very much dependent on the information that we ascertain from those sites. We'll need a way to also define some non-spatial information, so the catalogs of systems and processes, but also the constraints. So the operating parameters, the temporal dimensions of what we're working on, and thinking about the flow-through requirements in terms of consumables, in terms of the engineering requirements for that infrastructure as well. Next slide, please. In effect, the questions that we have ahead of us are the questions about how we're going to move forward from geologic maps into tracking materials and tracking the assets that we place in amongst those environments on the moon, to be able to inventory those materials, to track not just the materials themselves, but also the transformations that we're exercising upon them, and map the network of those transformations to the processes, the physical equipment and assets, and the stakeholders and players who are involved in transforming those materials into the usable products and components that we'll need to build our lunar infrastructure. We need that information because at this stage, we want to be able to model the trades that will have consequences for us way down the line when we're thinking about what types of materials we want to use to build our bulk infrastructure, when we're thinking about how we want to site and situate both our major infrastructure and how we want to configure it, configure the elements of that infrastructure in relation to each other. We also are going to want to be able to validate and log our knowledge about those materials by testing them in situ, by evaluating them in situ, and integrating that material information and those specifications about the geotechnical properties of the materials we encounter and how they behave in architectural and engineering contexts. In effect, over the long term, what we could do if we want to think way beyond where we are now is to be able to build an infrastructure that tracks that material information in context so that when we have a challenge ahead of us, such as building infrastructure in an austere environment, we can, in effect, solve for X by inputting our parameters, by taking the information that we have, and having a formalized approach to designing for austere environments anywhere we happen to go. Next slide, please. What I'd like to advocate for here, and probably a term that you've been hearing over and over, is architect from the right, execute from the left. I would also advocate that we envision our data infrastructure and our data products from the far end of that timeline, envisioning what kinds of infrastructure and data products we'll be using when we have the, in effect, digital twin for our lunar infrastructure. So we want to be envisioning from the right and then articulating from the top left and working downwards, defining the second order and third order data product and information that we need, as well as the non-spatial data, and building, in effect, our regolith to residence data loop. Next slide, please. So what we did recently as a precursor to this year, I worked with an intern in the MIRA program, and we undertook a study of what kinds of tools are currently available for cataloging materials data and thinking about how we want to configure materials data when we're working with that information in situ. And looking at the examples, MRDS being one of the ones that has been useful for me personally in a terrestrial context. Next slide, please.
1 minute.
And so we looked at a variety of examples, looking at the desirable features, the desirable content, and ultimately concluded that an integrated tool, such as we will need when we're making big and consequential decisions for infrastructure on the moon, An integrated tool for materials data doesn't exist yet, and none of these current tools have all of the features and information that would be desirable. Next slide, please. Our long horizon capability that we want to aim for is the ability to undertake geologic mapping in a holistic context, thinking about the resources that we'll need, their proximity to the sites where we'll be conducting our work, where we'll have positioned our assets, and thinking about how they fit into the supply chain, how they fit into the balance of supply and demand, and also the timelines for development of that infrastructure, positioning of surface assets as missions unfold over the coming years. We'll want to be able to take that local knowledge and data and link it to our knowledge base of materials data about the kinds of admixtures and additional inputs that interact with those materials that are well matched to them, and about how they perform, and then also ultimately about where it goes in its life cycle when we're taking those materials and reusing them inside our closed system of infrastructure that we're building. We want to be able to ultimately build robust tools for the big, long reach decisions that we'll be undertaking. Next slide, please.
Sarah, we got some discussion.
So in effect, what we want to be able to do is take that data and integrate it, collate it, as was being said earlier, and unsilo it, seek community input from our stakeholders, define those data formats, as has been said a number of times, and enable that interoperability for that decision making, so that we can have a supply chain that we can evaluate from one end to the next and from one cycle through the next. And in effect, that's what I have to say, and I really appreciate and want to thank Jim for having me here.